think we're ready now to look at PyTorch tensors. Okay. A tensor is essentially another way of looking at multidimensional data. It's extremely similar to NumPy arrays in that you can have any dimension, you can access elements in essentially the same way. But let's talk about a few of the differences. So one, let's say we have, here, let's take this first array. Let's say we have this array data and we want to convert it into a tensor. And the reason you would want to do that is before moving it into some kind of neural network. So let's say tensor data equals, and you would do that with torch.tensor. Remember that we imported torch there at the beginning. And then you put array data. And now if we look at tensor data, it should look almost the exact same, except now it's of type tensor. If we want to, it's actually very simple to go back from a tensor to NumPy, or to a NumPy array. All you have to do is take your tensor and then put .numpy like this. So this one is an array, this one is a tensor. Okay, great. So you can create tensors in extremely similar ways to creating arrays. So for example, something that's very common is, let's say you want a 0 tensor. We want it to be this size and shape, but we want it to actually be all zeros. So the way we would do that is we could say torch.zeros like, and then you can put any tensor object in here and it will replicate the shape and size but fill everything with zeros. And now, oops. Okay, and then if we look at 0 tensor, you'll see it's the same shape, same size, but all zeros. Great. Okay, one last thing with tensors, or two more things with tensors is, first we're going to talk about GPUs, how to move a tensor onto a GPU, and then lastly, working with the shape of a tensor. So in Google Colab, it's really helpful when you're doing neural nets to switch all of your tensors right before they pass through a neural net to be on a GPU. And the way you have to set up a GPU in Google Colab is you have to switch to a GPU runtime. So I'll show how to do this. Essentially, you go up here on the top right where it shows your resources. You click on this arrow. You can say view resources. And then from there, you say change runtime type here at the bottom. And then there are hardware accelerator options. You're going to be clicking on GPU, and then you can say save. And it will actually refresh your whole session. So everything that we've run so far, we're going to have to rerun if we need it. So we need to import these libraries. And we also need to get this array data that we're going to use. And so down here, we can just rerun these two again. Okay. So now, if we want to put, let's say, tensor data, if we can see what kind of device it's on, we can see if it's on your CPU or on your GPU. And the way you do that is by saying tensor data.device, and now we can see it's on CPU. So now if we actually want to move that onto the GPU, we could say tensor data.CUDA like this. And now if we print tensor data.device, it's connecting to the GPU. Now it says CUDA, which means that this tensor is ready to be passed through a neural net, which will make a lot more sense later on in the course. Okay, the last thing that we're going to look at is manipulating tensors. I'm just going to do two. So one thing that you can do with a tensor is, let's say that we have this tensor and it is 2 by 3. Let's say that we want to, so we can actually see the shape of that. Let's say that we want to add another dimension to the 0 tensor. Not add any more values, but just add another kind of redundant dimension. So we could do that with the unsqueeze command. And let's say we want to put that additional dimension as the first dimension. Wide tensor.shape. So now let's look at the shape of that. And now it has the same dimension except an additional dimension. And if we want to do, if we want to reverse that effect, another example is you could do the squeeze function. So let's actually take wide tensor. So in this case, we're taking thinner tensor, and we're saying that thinner tensor is equal to wide tensor, but just squeeze out that first dimension. So get rid of it, it's redundant anyway. And now let's print that. Oops. Great. Yep. And so there are other ways that you can work with the data. We could instead of just squeezing that, we could have also just said reshape it to be 2 by 3. That's another option. So it takes your data and then it maps those values onto an array with the same amount of values, but just reshaped in a different way. So that would do the exact same thing. So in your assignment, you'll see more of things like this, and it's going to get your brain turning on how to work with n-dimensional data. And hopefully this has been helpful.